Hey everyone, Matt here with another episode of Quick Compounds. In the previous episode, I showed you the logic behind a simple bulge deformer. This time, I'm going to build a compound that transfers vertex color data from one mesh to another. Vertex colors, or CPV, are used for all kinds of things, like storing lighting information for game engines or prelighting, or creating variations of reusable environmental textures, just to name a couple. I'll start with some simple primitives, a sphere and a torus. Now, before creating my Bifrost graph, I'm going to first paint some CPV data onto the sphere by going to Mesh Display, Paint Vertex Color tool. In the tool settings, I'll set the channels to RGBA and then paint some random colors around it. Note that this automatically creates a color set to hold these colors, which I can see in the color set editor. I could create alternate color sets too if I wanted, but for now I'll leave it with just this one. Now I'll create my Bifrost graph and middle drag the two shapes in. Now let's try the absolute simplest method possible by literally taking all the sphere point colors and plopping them onto the corresponding torus IDs. So I'll start by grabbing the sphere's colors with a getGeoProperty node. I'll plug the sphere in and set the property to color set 1. Remember, that color set was created automatically when I started painting on the mesh. For this type field, I'm going to create a value node of float4 to represent the red, green, blue, and alpha, or RGBA, values that color data holds. I'm also going to make it an array, since I want to store the color value of each point on the sphere. Now that I have those sampled colors, I want to set those same colors on my torus using a setGeoProperty node. This time, I'll use the torus as the input geometry and color as my property, since that's what a BIF object has. The default value of this will just be a plain old float4, not an array of them, since I'm not using it to store the color data this time, but rather to set one color on each of the torus's points. And then I'll output the result. If I hide the original torus now, you can see it looks like it's working. However, if I rotate the sphere, the colors become out of sync. This is because right now I'm porting the colors straight from one set of vertex IDs to another, but there's no guarantee about how those IDs line up. In fact, there isn't even any guarantee about both objects having the same number of vertices. Instead, what I need to do is sample all the points on the torus and then find the closest location on the sphere to each of those points. This mapping will allow me to find the right vertices on the torus to apply each color to. So first I want to sample all of the points on my torus, which I can do with a getPointPosition node. Next, I want to find the closest points on the sphere to each one of those torus points. I can do that with a getClosestLocations node. So this takes the array of torus points we just made, as well as the sphere mesh we want to find the closest points on. And it outputs a bunch of the closest locations on the torus surface. Note that these locations can be on vertices, or they might be in the middle of faces or edges as well. Now that I have my mapping, I just need to sample the color from one object and apply it to the other. To get those values, I'll need to use a sample property node instead of a getGeoProperty node. Whereas the former got a single property from a specific point ID, the latter gets the average of the properties closest to a location on the mesh. I'm sampling the sphere at each of the closest locations I just found. This also needs a default value of float4, which I can just reuse, and a property of color set 1. Then I'll just plug this into the data port of my setGeoProperty node. Now I can modify the original sphere and the torus colors adapt accordingly. Now I can bundle this up into a compound called transfer nearest CPV. To make things clearer, I'll call my inputs source mesh and target mesh, in order to specify where I'm getting the color from and applying the color to. Next, I'll add just a bit of extra functionality. Instead of just assuming my CPV data is coming from color set 1, let's make that an input value that the user can specify. This will be handy if the user has more than one color set on their object. I'll just call this input color set. Next, notice that the Get Closest Locations node has this handy cutoff distance setting. I can use this to specify a specific distance to sample values within if I only want to transfer CPV data in places where the objects are very close together or even touching. Great. Now there's only one last thing I need to do to make this useful, but to show you, let me import some more practical meshes. So here I've got two faces, a human bust and an ogre mesh. The human has some CPVs already applied to it that I want to transfer over to the ogre. So I'll just plug them into the appropriate spots in my compound. Great, so this has done a nice job of getting me a head start on my ogre CPVs. They aren't perfect, but obviously the models don't line up one-to-one. What I'd like to do now is go in and touch them up with a brush. Except, right now I can't do that because this is a BIF shape. What I need to do is output these colors to a polygon mesh. To do that, I need to use the node editor. Why the node editor, you might ask? Well, think of it like this. The Bifrost graph lives in its own world that just happens to be referenced by Maya. However, the graph itself contains only Bifrost-specific nodes and information. It's less concerned with who's outside its walls, feeding it information. Thus, anything from this outside world, such as my Maya geometry, needs to be fed into Bifrost through input nodes and receive data through output nodes. Hence the node editor. So in the node editor, I'll select the Bifrost graph and show its connections. Here you can see the graph is already feeding my BIF shape, which is what you currently see in the viewport. In order to get it to actually build a polygon, I'll need to create a Bifrost Geo to Maya node. This node accepts the out geometry of the Bifrost graph, then builds a Maya mesh, which I need to feed into a shape. Any shape node will do, so I'll just create a random primitive like a cube. Then, instead of building it with polycube, I'll just feed it with the Bifrost Geo to Maya mesh instead. This gets me a brand new, fully modifiable polymesh. However, it doesn't have the CPV data of my BIF shape. That's because we used the color property earlier. However, Bifrost Geo to Maya requires us to use the property point color. But rather than just replacing the property here, I'm actually going to copy and paste my set geo property and daisy chain it into my graph. Then I'll set this new one to point color. Doing it this way ensures both my BIF object and polygon object will have the input object's colors. And there it is. Now the polygon version of my ogre has the same vertex colors. And if I were to disconnect my Bifrost Geo to Maya node, the ogre mesh retains the CPV data, allowing me to go in and do some manual touch-ups. Not bad for such a little compound.